we talked about function operations, so our addition, subtraction, multiplication, and division. Today we're going to talk about function composition. So what composition is that it happens, you're going to take one function, so they're going to give you two functions just like they did yesterday, but you're going to take one entire function and you're going to substitute that expression, that function, in for the variable of the other function. Let me show you what I mean. So for this one here, they've given us two functions, our g function and our f function. So the way that we read this function composition, this open dot here can sometimes be confused for multiplication. This is not multiplication. If this was written as g times f like that with like a little dot, that's your multiplication. When you see an open dot like that, that's a composition. That means you're going to substitute one function into the other. And the way we read this is we read it g of f of a. So g of f of a. So what you're going to do, and sometimes I like to rewrite it, g of f of a, so that you can see which function is considered your inside function and what side is considered your outside function. Because you're going to take the f function and you're going to plug it into the g function. Just like if I asked you to find g of 2, you would go to your g function and you would put a 2 in for the a. Instead of us finding g of a number, we're finding g of the other function. So you're going to take that entire other function, you're going to take this whole thing, a squared minus 3a, and you're going to substitute it right there in place of a. So it's still a substitution, but you're just substituting one function in for the other. So g of f of a. So what I like to do is I like to go to my outside function, so my g function, and wherever I see my variable, I like to just open up a set of parentheses instead of writing that variable down, and then write the rest of the function. So my g function was a plus 1. But instead of the a, I'm going to put the entire f function in its place. So I'm going to take the a squared minus 3a, and I'm going to put it in place of a in g. I know that's a lot of letters. So, and then from there you simplify. So for this particular problem, these parentheses, they don't really mean anything. They're just giving me a place to put stuff. So g of f of a equals, just write this in standard form, a squared minus 3a plus 1. And just like when we were doing our operations, if this is just a variable here, it's just naming the variable that's in your functions, then your answer is going to be an expression. They call this like a rule. So if you do this composition, then you get a new rule. You write a new rule. Let's try another one. Okay, so for this one, this gives us an f function and a g function. And they're asking us to find f of g of n. Again, I always like to rewrite it f of g of n so that you can see which function is getting substituted in. So you're going to go to your outside function, your f function. So your f function is negative n minus 3. But in place of this n right here, we're going to substitute the g function. So again, like I said, I like to just kind of open up a set of parentheses. So it's negative n minus 3. And in that set of parentheses, you're substituting the g function. So your g function goes in these parentheses. So you get negative 3n plus 5. And then from there, you just want to go ahead and simplify as much as possible. So we're going to distribute our negative. So this will give us a 3n minus 5 and then minus 3. So f of g of n equals 3n minus 8. feel like I want to do one more with you. Just make one up. Okay, so say I have f of x equals x squared plus 3. And I have g of x equals x minus 1. And I want you to find f of g of x. So why don't you pause the video, see if you can do this. Okay, so finding f of g of x. So what you want to do, f of g of x goes into the f function. So if I write it like this, f of g of x, then I can see I'm substituting my g function into the f function. So you're going to write your f function, which is x squared plus 3, instead of the x, open up some parentheses. So it's x squared plus 3. But in place of x, you're putting this whole g function is going to go right here in place of x. So you're going to put x minus 1 right here. And then you simplify. Now this, here's a quantity that's squared. So don't forget, when that happens, this becomes a FOIL. So we're going to FOIL this, x squared minus x plus 1. And then I have my plus 3 on the end. Combine like terms. So f of g of x equals x squared minus 2x, and then combine your constants, plus 4. Then sometimes they give you a number that you want to substitute here. This should be, we're going to change this to an open doc here, composition. Sorry about that. Okay, so g of h of negative 8. So there are multiple ways to do these, but the way that I like to do these, and usually when I teach a couple different ways, this is kind of the way that most of the students lean towards. So we're going to go ahead and show it this way. Take your composition and write it as g of h of negative 8. Okay, so now they've given us a number to plug in. So what you can do is you can first find h of negative 8. So h of negative 8. So what that means is you're going to your h function, everywhere you see an x, you're going to put a negative 8 in its place. So I get negative 8 squared minus negative 8. Then we're going to figure this out. Negative 8 squared is 64. Negative 8 minus, well, these double negatives here, that's going to turn it into a plus. So then we get 72. Okay, so we first had g of h of negative 8, but we know that h of negative 8 equals 72. So you can replace this with a 72. So now we are looking at g of, instead of h of negative 8, we're going to put the 72. So it's like you have to do a double substitution. You plug in the negative 8 into h to see what value you get, and then that value goes into g. So we had 2 times 72 plus 2. So 2 times 72, that's going to be what? 144 plus 2. And 144 plus 2 is 146. So that's your final answer. So you do like a double substitution for that. All right, we have one more Again, I apologize. This is a typo here. This should be an open circle for your composition. Okay, so we want to find g of h of 6. So rewrite it, g of h of 6. And then you just kind of work from the inside out. So h of 6 means we take our h function, your 3t squared minus 5, and you put the 6 in instead of t. So now we have 3 times 36 minus 5, which is 108 minus 5, which is 103. So h of 6 equals 103. Okay, so this value, 103, is going to replace the h of 6. So now what you do is you go to your g function, and instead of g of h of 6, we're going to find g of 103. So you take your g function, which is 2t minus 1, you put the 103 in instead of the t, and then you figure this out. So 2 times 103 is going to give me 206 minus 1, so that's 205. And that's your final answer. So you do a double substitution. Find the value of the inside function, take that number, and plug it into the outside function. Okay, that's it. Let me know if you have questions.